Hey everyone! Interpreting data is a core skill we need to hone as scientific investigators. We can use visual representations to display patterns, relationships, and large amounts of data to understand their meaning. In this video, we'll look at trends in ionization energy on the periodic table before having a go at interpreting ionization energy data from a graph. Let's go! First, we'll start by examining trends in ionization energy on the periodic table. Ionization energy is the energy needed to remove an electron from an atom or molecule. As we look at the periodic table, we can see that ionization energy generally increases from left to right across the period, the horizontal row. This is because as you move across a period, the number of protons in the nucleus increases, which increases the positive charge and pulls the electrons in closer. This makes it harder to remove an electron, so ionization energy increases. On the other hand, ionization energy generally decreases from top to bottom down a group, the vertical column, on the periodic table. This is because as you move down a group, the number of energy levels increases, which means the outermost electrons are further from the nucleus, so the atomic radius is larger. This makes removing an electron easier because there's less attraction to the nucleus as the electron is further away. It's like how the force between two magnets weakens as you move them away from each other. From this, we can also see that ionization energy and atomic radius are linked. So that's our trend in ionization energy as we see it on the periodic table, increasing left to right and bottom to top. You can remember it as moving clockwise around the periodic table. Now let's have a go at interpreting the ionization energy data from this graph. We can see here that we have two lines on our graph. This line represents the first ionization energies for these elements, and the second line represents the second ionization energies. The first ionization energy is required to remove the first electron from an atom. The second ionization energy is required to remove the second electron from an atom. The second ionization energy is always higher than the first ionization energy. This is because after we remove the first electron, the atom becomes a positively charged ion. This positive charge makes it harder to remove the next electron, because the positive charge of the nucleus is now attracting the remaining electrons more strongly. This trend continues with each successive ionization energy. Each subsequent ionization energy is higher than the last because it becomes increasingly more difficult to remove electrons as the ion becomes more positively charged. But you might have noticed that the difference in first and second ionization energies is unequal for all the elements on this graph. Take a look at the first and second ionization energies for magnesium compared to lithium. There is only a small gap between magnesium's first and second levels compared to lithium, which shows a large increase. So why is that the case? The drastic increase in ionization energy from the first to second electron in lithium is due to the change in energy levels. The first electron being removed is in the second energy level, while the second electron is in the first energy level. The first electron is relatively easy to remove because it's in a higher energy level and further from the nucleus, so it's less strongly attracted to the positive charge of the nucleus. However, once that electron is removed, the remaining two electrons are in the first energy level, much closer to the nucleus and much more strongly attracted to it. Therefore, removing one of these remaining electrons requires a lot more energy, resulting in a drastic increase in the second ionization energy. This is a common type of graph you'll come across in your chemistry studies. So now you know what it means and how to interpret the information. So let's sum up with some questions. First, what are the trends in ionization energy on the periodic table? As we move left to right across the periodic table, ionization energy increases because the number of protons in the nucleus increases, placing a stronger pull on the electrons. As we move top to bottom down the periodic table, ionization energy decreases because the number of energy levels increases, which means the outermost electrons are further away from the nucleus. And finally, how can we interpret the data on this graph? A graph like this one shows the difference between first and second ionization energies for the elements provided. We can interpret two things from this graph. First, the second ionization energy will always be higher than the first because the atom becomes a positively charged ion after the first electron is removed. This positive charge makes it harder to remove the next electron because the nucleus is now attracting the remaining electrons more strongly. And second, a drastic increase in ionization energy from the first to the second electron is due to the change in energy levels. See you next time!